Are we rolling? Yeah, intermission is over. Now I think it's probably a good time just to do a few examples. So I'll write up just a few big numbers. Why do I keep doing 3, 5 for some reason? Okay, so we got that guy. So here'd be an interesting exercise. Take that guy and try to write it in scientific notation, and also try to write it with a metric prefix. So since we're going to do with the metric prefixes, let me give this guy some context. So it's 870. This guy is 870 million. So let's say it's 870 million
gallons of water.
Well, I'll just say meters. Okay, which is a long way. So let's try to write that guy with in scientific notation and also with the metric prefix. So to do it in scientific notation, the rule for the scientific notation is, we come back over here. The rule is you've got some number, and that some number here, the 3.5, the rule on that is that number should be between 1 and 10. And then it's multiplied by 10 raised to a power, and that power should be an integer. So here we got 870 million meters. So we're going to write that in scientific notation. So any ideas how to proceed from the cameraman? We'll put the cameraman on the spot today.
87 times 10 to the 7.
Okay, so it's 87 times 10 to the 7. Okay, so yeah, I never try to do it in my head. I just do this. So he's got the right idea. So we go 1, 2, 3, 4, 5, 6, 7.
Oh, 8.
Oh, you change your mind. You want to
Yeah.
go 8. Okay, and then is it 87?
What?
You said 87 times 10 to the 7, but we got
No, now
here.
it's 8.7.
Yeah, exactly. So you're right. The rule is, good job. So the rule is you want the number to be between 1 and 10. So you want the decimal right there. So we're left with 8.7. And we had to move it once, twice, 3, 4, 5, 6, 7, 8 times. So it's 8.7 times 10 to the 8th meters. Okay?
Yeah.
So now let's see if we can write it using a metric prefix. So you look over here, and there is no 10 to the 8th guy. The metric system, you know, we tend to have names for every third power of 10. So we don't have a 10 to the 8th. So we got two choices. We got 10 to the 6th and 10 to the 9th. I'm going to go with the 10 to the 6th. Okay? So we'd kind of like to write this guy in terms of 10 to the 6th. So I'm gonna do it step by step here. 8.7 times. So we got a 10 to the 8th. If you remember from the exponents, if you guys remember this, x to the a times x to the b is equal to x to the a plus b. Okay?
Okay.
So I'm going to take this 10 to the 8th, and I want to get a 10 to the 6th in here. So if I want a 10 to the 6th, what else do I need to make that guy work out?
10 to the 2.
10 to the 2, exactly. You see? So if I break it up that way, 10 to the 2 times 10 to the 6th is 10 to the 8th.
Yep.
So now I got 8.7 times 10 to the 2, and the 10 to the 6 is a million, which I could just use that. So I can call it 8.7 times 10 to the 2 megameters. But it kind of sounds funky that way. You tend not to use the metric prefix in conjunction with scientific notation. So what's 8.7 times 10 to the 2 equal to?
Who, me?
Yes, you. It's either you or Yoda, the only two people I can ask questions to. Yoda. It's either you or Yoda are the only two people I can ask questions to. So you could do a trick. You kind of undo the scientific notation. What's 8.7 times 10 to the 2?
Oh, 100.
Okay.
Oh, wait, you gotta, yeah.
So you got this 8.7, and 10 to the 2 means it's 2 decimal places bigger. So we can move the decimal over here, and then one more spot we need a 0. So 8.7 times 10 to the 2 is 870. And so we can say that guy is 870 megameters.
Oh,
Okay? Which sounds better, it rolls off the tongue better than 8.7 times 10 to the 2 megameters.
yeah.
Okay, so I'll come back and do one more example with the small number. Cut, cut, cut.